To solve another Leetcode problem, verify preorder serialization of a binary tree. So one way to serialize a binary tree is to use preorder traversal. So when we encounter a null node, we record the node's value. If it is a null node, we record using a centennial value such as has. So this example, let's just check this example. So for example, we have 9, 3, and 4. This is a preorder traversal. So after that, for the left and the right child, it's going to be has and has, and then we're going to traverse the node 1. So for node 1, after 1, it's going to be has because for 1, left and right, it is none. Yeah, and then we're going to, so this is the left child, and then we go to the right child, it's going to be 2 with a has. So left child is going to be a has, and then we're going to go to 6. So for 6, we're going to use has. Yeah, so this is going to be the preorder traversal. So first we're going to traverse the root node, it is 9, and then we go to left and right. Yeah. So the problem is that for such kind of problem, we need to recognize what is a leaf node. So if we find a leaf node, and we're going to turn this leaf node to something else. So for example, this 4 going to be a leaf node. So if this is a leaf node, it is represented by 2 has, with this node 4 and 2 has. But for us, we need to remove this leaf node in order to get this node 3. But how can we remove that? We have a 4 has represent this going to be a leaf node, so we're going to remove it with a has. So we're going to remove 4 has with a has. And similarly for this 1 has, we're going to remove it and replace it with a has. Now we have has for this node 3. So we're going to remove this node 3 and replace it with a has. Yeah. And similarly for this node 6. So for 6 has, we're going to remove it and represent it as a has. So what about this node 2? Because at the left child it is a has, so we're going to prepare has. So has with node 2, we're going to remove node 2 and replace it as a has. And similarly for this node 9, it's going to be the has with 9. So we're going to remove this node 9 and replace it with a has. Yeah. So for the tree traversal, it's going to be a preorder traversal. But for us, while we are solving the problem, actually, we are also checking the, according to the preorder traversal, we are also checking the left child and then right child and then go to the root. Yeah, but for the preorder traversal, it is the root, left, and right. But for us, while we are solving the problem, we're going to first check the left and then the right child and then the root. It seems that it is like a post-order traversal, but that is the trick. So let's just use this kind of idea to solve the problem. But before that, let me simulate one example. So this is going to be our string, and we're going to check it from the left to the right. If we find a number with 2 has, yeah. So if we find a number, after that it's going to be 2 has. What are we going to do? We're going to replace it with a has. And similarly, we're going to check. So 1 with 2 has, we're going to replace it with a has. Now 3 with 2 has, we're going to replace it with a has. And now 6 with 2 has, we're going to replace it with a has. And 2 with 2 has, and we're going to replace it with a has. Now 9 have 2 has, we're going to replace it with a has. So the final return is going to be a has. So if the final return is a has, it's going to be true. Otherwise, it's going to be false. So this is just the idea. Now let's just use a stack to simulate this kind of operation. Yeah. So for character in preorder, we're going to use a split with the comma, and yeah, we need to put it inside. And we want to check if the length of the stack is more than or equal to 3, and stack minus 1 equal to a has, and stack minus 2 equal to has as well, and stack minus 3 not equal to has. Yeah, so this is just my simulation by using the stack. If it is not like that, but we should not use if, because this is going to be a while loop. If it meets, while it meets the conditions, we're going to continue to do such kind of operation. So the operation is going to be for I in range with 3, we're going to pop it first. So stack dot pop. So after we pop it out, we're going to put it inside. I think this operation is going to be much easier if we write it like this. Yeah. So for I in range 3, we pop and then we append the hash. So finally, we just need to check if the stack equal to an array and inside it's going to be a hash. Now let me just run it. It seems something wrong. Let me check. Yeah, let me just print out the stack to check what is wrong with it. Normally my stack I should have a hash. Now let me check what is inside my stack. It seems inside my stack there's everything inside, definitely, and there's something wrong with my code. So first of all, I just put it inside, and if the length is more than or equal to 3, and the stack -1, -2 should equal to hash. Yeah, and -3 should not equal to hash. So this is what I met by the simulation. Yeah, we always want to find 2 hash with a number like this. This is by -1, -2 hash, and -3 with a number. Now let me just submit it to check. As you can see, it works and it's pretty fast. As while we are using our stack, so the time complexity is going to be O(n) and the space complexity is going to be O(n). Thank you for watching. See you next time.